Let's start with the scale. Even if you traveled at the speed of light, it would still take you over 1 billion years to cross the Kipu structure. That's not a typo. 1 billion years, just to move from one side to the other. And yet, Kipu only makes up about 13% of the observable universe. Still, it contains more mass than your mind can possibly imagine. Over 200 quadrillion times the mass of our Sun. So what is Kipu? It's a cosmic superstructure, a massive filamentary network of galaxies, gas, and dark matter that resembles a spider web stretching across space. But this is no ordinary cluster. It's a piece of the cosmic web, the large-scale structure of the universe itself. Its name, Kipu, comes from the Incan system of knotted cords, also known as quipus, used to record numbers, dates, and even messages in the form of knots and threads. Each twist, knot, and color held meaning. It was an ancient form of communication. Astronomers chose this name not just for its poetry, but because the shape of this galactic megastructure resembles those cords. A long central filament with branching tendrils, just like a woven knot of space. And here's the wild part. Kipu isn't alone. When scientists mapped this region of space, they discovered 5 similar tangled structures nearby, all stretching billions of light-years across. These structures didn't just appear overnight. They formed over billions of years as gravity slowly pulled matter together into filaments, walls, and voids, shaping the architecture of the cosmos. This arrangement, with galaxies forming along the filaments and vast empty regions between them, is what we now call the cosmic web. It's how the universe organizes itself, not in neat rows, but in knotted, twisted strands of light and matter, held together by dark matter scaffolding. To give you an idea of its complexity, think of it like this. If the universe were a forest, galaxies would be the trees. But Kipu is the roots, the mycelium network, the hidden infrastructure connecting everything together. And while we've long known that galaxies cluster into filaments and sheets, Kipu has pushed our understanding to an entirely new level, in both scale and structure. Its sheer size, density, and organization challenge what we thought was possible in the timeline of the universe. How could such a large structure form so quickly after the Big Bang? What forces molded it into these elegant, cord-like shapes? The answer might lie in the dark forces that shape the universe, especially dark matter and dark energy. These invisible forces are believed to make up 95% of the universe, but we can't see them directly. Instead, we observe their fingerprints, the motion of galaxies, the bending of light, and the formation of massive structures like Kipu. Kipu also teaches us something deeply humbling. The universe is interconnected. From tiny subatomic particles to colossal galaxy filaments, everything is part of a larger system. And just like the Incan quipus told stories through knots, the universe is telling a story through the geometry of its galaxies. A cosmic language, written not in words, but in gravity and light. And we're just beginning to decipher it. Astronomers are now using AI, deep space telescopes, and gravitational lensing to map even more of the cosmic web. Future instruments like the Euclid Space Telescope and the Nancy Grace Roman Telescope will allow us to peer deeper and farther, revealing even more of the hidden skeleton that holds the universe together. So what does this all mean? It means that when you look up at the stars, you're not just seeing dots of light. You're seeing nodes in a vast cosmic network. And you, me, our planet, our sun, we're all woven into this grand design. It also means we're part of a universe that's alive with motion, with galaxies flowing along invisible strands, colliding, merging, and evolving, all within a framework as intricate as it is enormous. Kipu is more than a structure. It's a symbol, a reminder that the universe isn't just chaotic. It's structured, interconnected, and perhaps even intelligent in its design. And as we explore its depths, we're not just uncovering the history of stars, we're unraveling the architecture of existence itself.